Okay, so for FC2, we're going to do this problem right here, y equals -2. If you remember last time, we did for FC1 the problem x equals 3. X equals 3 turned out to be a vertical line after we plotted the table and made the dots and everything else. Let's see what happens with y equals -2. In fact, y equals -2, its name is a horizontal line. And we'll see in a moment why it turns out to be horizontal instead of vertical. Now if you look at the equation, it says y equals -2. What that basically says is y can only be -2. If you look at x equals 3, x could only be -3 last time. So y equals -2 tells us y can only be -2. And so that will help us make or build our table. Since y can only be -2, that means no matter what x we use, we can only have one y answer. Again, no matter if x is -1, if x is 0, if x is 1, or if x is 3, you can pick any x you want, 5, -5. You're only going to get y to be -2. Plotting these tells us put a dot at -1, -2. Put a dot at 0, -2. Put a dot at 1, -2. Put a dot at 3, -2. And if you look at all those dots and you line them up, and you get your ID card, your ruler, your protractor, or something along those lines, you can see those dots are perfectly side to side, which is going to create a nice little horizontal line for us. Now, going back to the top, what is the transformation equation for a horizontal line y equals -2? Well, a horizontal line always has the same transformation equation as what it is. Why is that? Well, the parent function for this problem is y equals 0. Again, if you go back to FC1, the parent function for x equals 3 was x equals 0. The parent function for y equals -2 is going to be y equals 0. For FC1, the parent function x equals 0 is a vertical line through x equals 0. For FC2, the parent function y equals 0 is going to be a horizontal line through y equals 0. So there's some consistency and yet slight differences already. Did you draw a function? Yes. Why do we know it's a function? Well, if you remember from middle school, there is something called the vertical line or the pencil test. Vertical line test or the pencil test. That means if you roll a pencil from left to right, does it touch one location at one time? The answer is yes. It never touches multiple locations at one time. So this is indeed yes. What is the domain? The domains are the x's only, and the ranges are the y's only. So if we can remember, y can only be -2, that means for the range, y is only -2. But for the x's, if you recall when we made the table, we basically said x could be anything. And since x could be anything, x could be any number that we possibly can think of. And the symbol for that is this backwards R with another slash behind it off of its ponytail or a backwards baseball cap. From middle school, you've probably had this memorized at one point in time, but you forgot it. a horizontal line must have a slope of 0. Does a horizontal line have a vertex? No. Does it have an axis of symmetry? No, not quite. No, we'll talk more about that later on. Is this increasing or decreasing? Well, it's not really going up or down, it's just going left to right straight across, so that's not quite it either. What about x-intercepts and y-intercepts? Remember from FC1, when we did the x-intercept and the y always was 0, when we did the y-intercept, the x was always 0. So we're going to do that here. For the x-intercept, the y must be 0. For the y-intercept, the x must be 0. Again, something from Algebra 1 that you've forgotten and will memorize very, very soon. Now, for the y-intercept, x must be 0. Now, what y must be connected with that x equals 0? Well, remember what our pre-work said. Y can only be -2 for this problem. So we're going to go ahead and say the y-intercept is 0, -2. Now what about the x-intercept? If y can only be -2 and the x-intercept must have a y equals 0, what are we going to do in this case? Well, this is going to have a conflict. It's not going to quite work out for us on this one. At least that's what the math says. And if you look at the picture, does it actually touch the x-axis to get an x-intercept? No, it does not touch. So the math has an issue, and there's a reason why this is the math reason for why it does not touch. Now, what is the horizontal and vertical asymptotes? There aren't any. We won't worry about that until January, maybe even February. The maximum value is the high point, and the minimum value is the low point. Does this have a high point or a low point? Well, it doesn't go up or down. It doesn't have a high. It doesn't have a low. So there's not really a max and there's not really a min. Okay, so we got most everything. What about the verbal description? Well, let's look at the verbal description for our FC1. We're going to do something very, very similar. Instead of saying the vertical line, we're going to say the horizontal line. Moved the parent function for FC1 it moved it 3 spaces to the right. If you look at the parent function, it went from here and it slid over to there, 3 spaces to the right. Went from 0 to 3. So if you look at our problem here, it's going from our 0 down to -2. So it's going to move the parent function 2 spaces down. It has a domain. And if you go look at it, all real numbers. A range of y equals -2. Okay, I'm just following along here. A range of y equals and a y-intercept of, what was it, 0, -2. Doesn't have an x-intercept, this time has a y-intercept. The slope is m equals 0, and there is no x-intercept. Something along those lines would be perfect. So your description always mentions some comparison to the parent function, always talks about the domain, the range, the y-intercept, the x-intercept, and some mention of slope.